In this video, we're going to look at an application of systems of equations, specifically the interest question. Okay, so this question says a total of $17,000 is invested into two accounts. One account pays 5% interest per year, and the other account pays 6.5% interest per year. If the total interest after 1 year was $970, how much money was invested into each account? I find the best way to organize this information is in a table. We are given two totals. We have a total amount of money that was invested, and we have a total amount of interest that was earned, right? So we see this total given twice. So when I set up this table, I'm going to have piece, piece, total, piece, piece, total. So when I set this up, we're going to have the account that pays 5%. So account pays 5%, and we need, so that's going to be one column. And we're going to have another column for the account that pays 6.5% interest. Pays 6.5%. And then we're going to have our total column. Okay, now what are the two totals? This is money invested. So one, we're going to have money invested, which I'm going to do $ invested. Okay. And what's my other total? It says total interest. Interest is something that's earned. So when I write this, I'm going to say interest earned. All right, now these are my two unknowns right here. What we're trying to figure out is how much money is in each account. This is it, the account that pays 5%, this is what we want. We're going to assign this a variable. Instead of using x and y here, I usually will use the first letter of the number that it is, unless of course they're both the same. Like if it's like 6 and 7, you can't use s for both. But since it's 5 and 6, this one I'm going to call f, and this one I'm going to very carefully call s. S is not my favorite variable choice because it does sometimes end up looking like 5s. So be super, super careful. If you need to do something to differentiate your s from your 5, you should definitely figure out some way so that you don't make a mistake and then end up having a 5 somewhere and losing the s in the middle of the problem. Okay. Do we know how much was invested? Well, we know that the total amount invested was $17,000. So I'll put that in my total. Otherwise, we don't have any information. So this we're just going to call f, that there's f dollars invested in the account that pays 5%, and there are s many dollars in the account that pays 6.5% interest. Interest earned. So the interest earned, this is the one that's really tricky to set up. If you get 5% on whatever money is in here, now 5%, we can't actually use the percent, so we convert it to its corresponding decimal or fraction. I usually use the decimal, so it would be 0.5, and we get 5% of whatever is in this account. Right now what we know is in this account is f, so it's going to be 0.05 times f. This account pays 6.5% interest, so we would get 6.5% or 0.065 times however much is in here, which is s. Again, be very careful here. We have a 5 right next to an s, so it really can be tricky. Okay, so this is the amount of interest earned here. This is the amount of interest earned here. The total interest earned, it said, was $970. At this point, if you don't have a calculator handy, you might need to get one out. I'm going to hold on to mine. And the nice thing about the table is that once you have it, it just set up the two equations for you. Here's one, part plus part equals total. Here's the second one, part plus part equals total. So it would be f plus s equals 17,000 is equation 1. Equation 2 is 0.05 f plus 0.065 times s equals 970. Generally, we want to get the decimals out of the equation. We tend to make more mistakes with decimals and fractions. So the way that we can clear out decimals, we find the one that has the least place. This one goes to hundredths. This one goes to thousandths. Because this goes to thousandths, if we multiply everything by 1,000, that will move this over enough times to get it so that we no longer have any decimals. So I'm going to take this second equation and I'm going to multiply by 1,000. If I multiply this by 1,000, it moves the decimal point 3 places to the right, so we end up with 50f. Be very careful you don't end up with 5f. That would be a mistake. You need to multiply by 1,000, so we actually end up with an extra place here, and it becomes 50f. Plus 65s is equal to, and this we're going to add 3 zeros to the end, 970,000. Okay, so now the two equations I really want to work with are this one and this one. And because we have the variables on the same side and this one looked relatively nice to work with, I'm going to use the elimination method here. So I want one of my two variables to have the exact opposite coefficients. I'm going to use the 50 because that's smaller and a nicer number to work with than 65. So I want this to be negative 50f, so I'm going to multiply by negative 50. We would have negative 50f minus 50s is equal to negative, this is where the calculator might come in handy, I think it's like 17000 times negative 50, we get negative 850,000. Oh, I could have guessed that. Oh well, I didn't. I used the calculator to be sure. 50f minus 50f, those eliminate. 65s minus 50s will be 15s. 970,000 and negative 850,000, that would leave me with 120,000. Now we want to get s by itself. Let's divide both sides by 15. And we end up with s equals, brain's not working, but calculator works. So we're going to do 120,000 divided by 15, and I end up with 8,000. So what this means is that there was $8,000 invested in the account that pays 6%. So 6%, we have $8,000. I'm sorry, 6.5%. Let's try that again. 6.5% is $8,000, and the account that pays 5%, well, let's go back to one of our original equations. We know there's a total of $17,000, and this one has $8,000 invested, so the rest of it must be in the 5% account. There must be $9,000 invested in the account that pays 5%.